So the next thing we're going to talk about is, like I said, divisibility. Let a and b be integers. We say that a divides b if there exists an integer k such that b is equal to a times k. I mean, in other words, a divides b if b is a multiple of a. So that's what this equation means, right? B is equal to a times k, where k is some integer. So this really just means b is a multiple of a. The notation for this is we write a with a straight line, straight up and vertical line, b. So this means a divides b. Note that this is a statement, right? So a divides b is a statement, right? Which, so a statement is a thing which is either true or false, right? In particular, if I write this is not, okay, this is a mistake a lot of people make. This is not a number. Okay, this is not, for example, the ratio of a and b or something like that. A divides b is a statement. It's something which is either true or false. Okay, so either a divides b or it doesn't. Okay, so for example, if I take the number 7, so 7 divides 49, because 49 is 7 times 7. 49 is a multiple of 7. Negative 3 divides 12. So this one's maybe a weird one, but this does work with negative numbers as well, because 12 is equal to negative 3 times an integer, specifically negative 4. Okay. You can also do this with two negative numbers, right? So negative 4 divides negative 16, because negative 16 is negative 4 times 4. If a number doesn't divide another number, we write a little slash through it. So 7 doesn't divide 20. So this is a symbolic way of writing 7 does not divide 20. It's just like when we had things before, like x is not an element of a, that kind of thing. Or when you if you have something which is not 0, you write a slash through it. It's what we do with all mathematical notation. If you want to say something's not true, you just write a slash through the symbol. Okay. Any question about any of this? Yeah, hopefully this concept is probably kind of familiar to you, right? This is just saying, does a number go evenly into another number? With no, does it divide a number with no remainder? Okay. So let's see how you can prove things about this this divides thing. So I'm going to let a, b, and c be integers. And I claim that if a divides b and b divides c, then a divides c. So note that, these are statements, right? So this is saying this statement and this statement logically implies this statement. In particular, these are not numbers, right? This would make no sense if I write if a over b and b, that wouldn't make any sense, right? So, okay. Okay, where should I start here? And this is the same for pretty much any, anytime you're well, okay, maybe it's not always the case whenever you're proving a if this then that statement. But we want to, okay, we're going to do a direct proof. So I'm going to start by assuming that a divides b and that b divides c. Okay, we're going to assume this, and we're going to derive that a divides c. So we want to prove that a divides c. Okay, so what can so I'm assuming that this is true and this is true. What can I do with this information? Exactly, yeah. I'm going to go, so exactly what you should be doing is really, going back to your definition of divides, and using it. So because like writing, I mean, this notation just it's not useful, right? It doesn't mean anything to me in some sense. But what's useful is kind of unpacking what it means. So what this means is that since a divides b, we get that there exists an integer k such that b is equal to ak. And similarly, since b divides c, there exists another integer, let's say m, in the integers, such that c is equal to m times b. Okay. So this is just by definition of what it means for one integer to divide another integer. Any thoughts about what I should do with this? So in the end, I want to show that c is a multiple of a. Well, so we have something involving c. c is m times b, right? And actually, I know that b is a times k. I can kind of substitute in. So therefore, c, which is m times b, is also equal to m times ak, which is mk times a. So can anyone see why I'm done? We've expressed c as a multiple of a, right? It's something times a, where this something is an integer. So since mk is an integer, we see that, a divides c, because we've literally written c as a multiple of a, where the multiple, is an integer. So it's an integer multiple of a, and that's what we wanted to prove. So that completes the proof. If you think about what this statement really says, it's kind of clear, right? If b is an integer multiple of a, and c is an integer multiple of b, then certainly c should be an integer multiple of a, because it's just, you multiply by by two integers to get from a to c. Well, okay, let me give you another kind of quite a similar statement. So we can get a bit more practice with this. So here's proposition 5.5.4. So if a divides b and a divides c, then a divides the number xb plus yc for all integers xy all xy. This one's a bit complicated, right? Because there's like 5 variables going on, a, b, c, and x and y. But yeah, okay. So suppose a divides b and a divides c, and let x, y be any 2 integers. Okay. So we want to prove that a divides xb plus yc. So hopefully the logic here is clear, right? I mean, whenever you're trying to prove an if this, then that statement, like an if-then statement, you start by, okay, well, there are different ways to do it. You could, for example, take the contrapositive. You could do things by contradiction. There's lots of different ways to do it. But the most direct way of doing it is to say, we assume that the hypothesis is true. We try to prove the conclusion, right? So this is all I'm doing here. I'm assuming that these statements are true, and I'm trying to prove this statement for every x and y. Okay, so, right, what should I do next then? Any thoughts? It's kind of the same as last time, in some sense. Yeah, one thing there is backwards, but otherwise that's exactly what you want to do. So, yeah, exactly. So you want to take these statements and actually use them, right? So since A divides B, there exists an integer k such that. Now the one thing that might have been backwards in what you said, but it's yeah. So we don't get to write that A is k times B, but it's instead B is k times A. But otherwise that's exactly what you want to do. Yeah, that's right. Right, because yeah, we want to use this condition, right? Well, and since A divides C, there exists an integer m such that C is equal to m times A. Okay, now what? So we always have to remember where we're trying to get to, right? We're trying to get some information about, A dividing this thing, right? So how am I going to get that information? Like what am I going to, what should I do? Yeah, I mean, essentially we're going to kind of plug things into this. I think that's, well, okay. So we want to have our x b and y c, and plug in these kind of values for them. So therefore, if I take xb plus yc, that's x times ka plus y times ma, because c is ma, b is ka. So this is like, well, everything has an a in it, so I can factor out the a like that. And then why are we good? Like, why are we happy with this? Yeah, well, so when I expand it, it's equal. But actually at this point, I don't really even want to expand this. I just want to say, like at this point, this is an integer, right, times a. So we've demonstrated that xb plus yc is some integer times a. So it's a multiple of a, and that's what we wanted. So since xk plus ym is an integer, this equation tells us that A divides xb plus yc. And that's exactly what we wanted to prove. So we're happy. It's a little bit trickier, when I gave you examples like, okay, if 7 divides 42 and these kinds of things, this is kind of clear, understanding what division means. I guess it is a little bit more difficult when we're proving things about general numbers. I've got variables everywhere and what divides what and that sort of thing. But the key thing here is to be really solid on the definition. Like, what does A divides B mean? It means there exists a k such that B is k times A, right?